Topic 1C, design of experiments. So we're going to start out by talking about the design of a statistical study. So when you're designing a statistical study, there are 6 steps you want to include in that design. The first step is you want to identify the variables of interest and the population of the study. So basically, what do we want to know and who do we want to know it about? Got to know where you're starting, right? What do we want to find out and who do we want to find out about? The second step is to develop a plan for collecting that data. How are we going to find out those variables about that population? Right, so develop your plan, come up with your method, and we'll talk about some possible plans for collecting data. Once you've come up with your plan of how you're going to do it, collect the data. Right, you know what you're looking for, you know how you're going to get it, go get it. Collect that data. Fourth step, describe the data. That's descriptive statistics. You went out and you collected your data, now you're describing it. So descriptive statistics. Step 5, interpret the data and make decisions about the population. That's inferential statistics. Now that we've described our data, we're going to take that and say, okay, so what does that tell me about the population, or what can I infer about the population? And then the 6th step is to identify possible errors. Anytime you do a study, you should look and see where errors could come into this study. I do not trust any study that claims everything was done perfectly and there's no way it could be improved. As you go through a study, you always see things that are like, gee, it would be really nice if we knew this. Or, gee, wouldn't it have been nice if we had been able to put this together? Or, darn it, we should have done this. It's a given. If you are doing a study, you're going to run into something that could have been done better, an error that you found was made, or just, gee, it'd be nice if we had that additional piece of information. If you're claiming that none of that occurred, you're full of it, okay? There's always some way that it could be improved, and that's what we're looking for. And sometimes when you identify the possible errors, you realize that you've got to redo the study because you find such a glaring error or such a glaring problem that you can't leave it as it is. You have to redo the study to fix that. Okay? So the 6 steps: identify the variables in the population, develop a plan to collect the data, describe the data or descriptive statistics, interpret the data or inferential statistics, identify your possible sources of error. So let's talk about first of some vocab that we need, and then about ways we can collect this data. So here's some vocabulary that we can use. Experimental units. Experimental units are the individuals that are studied. Those are our experimental units. And if they are humans or living creatures, we tend to refer to them as subjects. So those are experimental units, those things that we are studying, right? Outcome or response. So the outcome or response is what's measured on each experimental unit. That's the outcome or response. We test their blood pressure and we find out what that is. We test their heart rate, we find out what that is. Those are the outcomes or responses for those experimental units. Treatments are procedures applied to each experimental unit, and there are always at least 2 treatments applied to determine effect on outcome. What I mean by there are always at least two treatments means that you have to have at least 2 groups with different things happening. You can't just perform some treatment on one group of individuals or items and not do something different to compare against. Okay, so that's treatments. So treatments are actually where we act upon the subjects or the experimental units. So let's talk a little bit about data collection. In fact, we'll just continue here. How can we collect our data? Well, there's a number of different ways, one of which is observation. Observation, we just observe and measure characteristics, but we don't change any of the conditions. We do not affect the experiment, at least that's the hope. With observation, all we're doing, we are strictly observers. We look and we record, but we try not to affect in any way, shape, or form. So those are observations. If I want to find out the type of cereal that people like to buy, by observation, I'm hopefully not going to affect how they shop for it, but I just put a hidden camera so I can see which cereal they purchase. That's by observation. Did not affect the outcome at all, but allowed me to see what was happening. Another method is an experiment. In an experiment, we do apply a treatment, and we do that to a portion of the population. Right? So with an experiment, we are getting in and affecting things. We apply a treatment and see how that's different from not applying a treatment. Wait, not applying a treatment? Well, that would be a control group. A control group in an experiment is the group that does not have a treatment performed. You don't want to just apply 2 treatments by themselves without having something that's staying standard where it was. So a control group, that is basically your baseline. You can watch that control group that does not have a treatment being given to it and see how the treatment fares compared to not having a treatment, having that control group. Well, we will see some problems with that because if you have a control group and you have a group that's getting a treatment, obviously the people in the control group know that they're not getting the treatment, and the people in the treatment group know they are. So we run into a problem there, so that's where we bring in a placebo. A placebo is basically a harmless, unmedicated treatment. Basically, we do something to make them think they're getting the treatment without actually affecting them. So we use a placebo, and we do that so that the control group does not realize they're the control group. We can perform simulation to collect data. A simulation will use a computer or something else to simulate or act as if this treatment was applied and see what happens. Simulation is used a lot when it's either too time consuming, too cost effective, or too dangerous, not cost effective, but too costly, or too dangerous to actually perform the experiment. If you think back to when I was young, and most of you did not exist, a very common concern was nuclear war, the atomic bomb, who was going to drop it on whom. And so they performed simulations using computers to determine what was going to happen. If they launched an atomic bomb at this location, what would be the response? And they would do this, and I'm glad they did, because I'd rather them do that than just lob a bomb over there and say, hey, let's see what they do. So obviously, there are times where simulations make it much safer for us to try things. It's really done all the time with car testing, safety crash testing. They put test dummies in there. Those test dummies are simulating what would happen to a human if they were in those vehicles. So for safety's sake, they do a simulation instead of the actual experiment. And then our final one is a survey, which everybody's familiar with a survey. That's where someone asks you a bunch of questions. And surveys can be done in many ways. You could have a paper survey where you fill it out and you turn it back in. You could have a verbal survey where someone asks you some questions and you answer. You can get an email survey and you answer the email and respond back. You could go on a website and fill out a survey like SurveyMonkey or Mr. Poll and things like that, and get and fill out the answers that way. So surveys are very common, and you can get a lot of information from surveys. So it's a very good method to use. Let's look at experimental design. Remember, experiments where we're applying some treatment. So looking at experimental design, well, there are still some more things that come into that, like confounding variables. Confounding variables are related to both the treatment and the outcome. They're difficult to determine whether differences in outcome are due to the treatment or the confounder. So we don't know whether the treatment caused the effect to happen or if the confounding variables did. Let's say I wanted to determine how long it takes people to get to school throughout the year. And I want to see if weather has an effect on that. So I go and I ask people their commute times throughout the year and the weather associated with that. And we go through and we find out that for some reason, in June and July, commute times increase. And according to weather patterns, June and July were very wet. Now I could look at that and say, all this rain or excessive wetness caused the commute times to get longer. So that could be the variable that's affecting it. Or there could be something else like June and July is when they tend to work on roads. And in June and July, they had torn out a bridge and were rebuilding it, so everybody had to go around extra distance to get to where they were going, therefore extending the commute times. So that's an example of confounding variables. They're ones that, is it the treatment that caused the change, or is it this other variable that caused the change? So that's something we have to be wary of. Placebo effect. We talked about giving a placebo to the control group so they didn't know that they were not getting the treatment. Well, the placebo effect basically says that mind over matter, what your mind believes can cause your body to react in certain ways or cause you to react in certain ways. So by giving them a placebo, they may believe that they're actually getting the treatment, and that may have an effect on the outcome. That could cause a change. So it's not the treatment that caused the change, but the thought that they were getting the treatment that caused the change. Such as if I am testing out new medicine to relieve depression, then getting a pill and thinking that it's going to help relieve your depression may actually cause you to be less depressed because you know that your pill is helping you not be depressed. When in reality, you're just getting a placebo, and it's just the fact that you think that you're not going to be depressed that causes you not to be depressed. So that's the placebo effect. Now with placebos, the way they work is blinding. Blinding is where the subject does not know whether they're getting the treatment or not. So and that's what a placebo does, is it causes them to be blind as to whether they're getting the treatment or not. So you can find out whether it's the treatment or just the thought of getting the treatment. Sometimes we go so far as double blinding, which means the test subject nor the experimenter know who's getting the treatment or isn't. Now, why would we want to make it so that the experimenter doesn't know? That seems a little odd, but it really makes sense because if the experimenter knows, they could potentially give information to the subject that would help them to know and throw things off, or they could, as they're studying and observing, they may pick up things knowing, well, this person is getting the treatment, so look, they're doing such and such, that's a sign that it's working, whereas they might not take it as a sign of working if the person wasn't getting the treatment. So double blinding helps to get it even more accurate. Well, then we get into randomization. How do we select who gets the treatment and who doesn't? Well, the first type of randomization we do is completely random. It's a lot like the simple random sample that we dealt with, right? We just randomize who gets the treatment and who doesn't. But just like the simple random sample, it doesn't guarantee that we get a good cross-section in either of those groups, or that that they match up nicely at all. Okay? So that's the first one, is completely random. The second one we do that gets it a little better is we use blocks. It's kind of like clustering, groups of similar characteristics. So then we group people into similar characteristics, and we make sure that we split those between the control group and the treatment group. So that allows us to get a little bit better. We know that we've split them up nicely. Going even further than that is randomized block design. We get into the blocks, and then we randomize or randomly select who goes into each. So we're kind of mixing this the randomization completely random and the blocks to get completely random blocks, or blocks that are completely random, who of those blocks goes into either of the groups. But the best thing we can do is matched pairs. Matched pairs means that we take two subjects that are as close to the same as possible. We try to get the same age, height, weight, gender, activity level, hair color, race, creed, everything we can to get them as closely matched as possible, and then put one in the control group and one in the treatment group. And we do that and find a whole bunch of matched pairs, and split them into the groups that way so we can get the best comparison. Now obviously when dealing with matched pairs, the best thing we could possibly do would be to get identical twins. If you can get identical twins, that's the closest you're going to come to having a perfect match. And that's why identical twins are sought after when you're looking to do experiments, especially medical and such, because they can get the closest genetic match and see what effect the treatment really has. Another thing that's very important when dealing with experimental design is replication. Replication. Can we repeat the experiment? To do an experiment once is nice, but if it can't be duplicated, if you can't do it again and get a similar result, then it's no good. It's invalid. So replication, we have to be able to repeat the experiment. Go and do it again and show that it works again. Then we go, okay, that experiment's good, that one worked, that's valid. So replication, very important. Back in the late 1980s, the University of Utah came up with cold fusion. They were able to create nuclear energy in a bottle, which is basically what fuels the sun, right? It's an unending power source. And because of that, the cars we drive are nuclear powered, our homes are nuclear powered, we get our heat from nuclear power, everything we deal with is nuclear powered because they came up with this in the late night. Wait, you say your car's not nuclear powered? Oh. Well, why is that? It's because this experiment that they did in the late 1980s was not replicatable. They couldn't duplicate it. They couldn't, and they gave the information to other people, and other people could not duplicate it. My guess, they had this tube that had a vacuum in it. It was supposed to be clear of everything, and they were going to try to do this, and they applied power, and there was some impurity in there that went poof, and they got a flash of light, and they said, hey, we did it, and they were never able to duplicate it again because they didn't have that situation again. So if it's not replicatable, it's no good, it's not valid. So let's finish off by talking about observational studies. So that was experimental design. Let's look at how we can do observational studies. And we tend to refer to these as cohort studies. Cohort is just a group. I am part of a cohort of teachers who got hired on at a certain time in Mohawk Valley Community College. So there's a group of us that came in at the same time, got to know each other at the same time, went through training together at the same time. So we were a cohort, and that allowed us to kind of bond. And now when we go to meetings and we're working on different projects, we go, hey, I know you, and we feel comfortable with those other teachers because we came in together and we were part of a set group. So cohort studies with observational studies are different groups that we study. And there are 3 types of cohorts that we deal with in observational studies. The first is prospective. So prospective studies. We take a group of people and we find out everything we can about them now pertaining to what we're interested in. And then at set time intervals for an extended period of time, we bring them back in and we find out that information again, and we find it out again, and we find it out again, and we find it out again. An example of this, if you're familiar with hydrofracking. Pennsylvania was doing hydrofracking and they started doing a study. And this was supposed to be, I believe, a 6 year or 10-year study. And what they did was they measured the, basically the ground and the groundwater in certain areas for different chemicals and different imperfections and things. And they tested that. And then with hydrofracking going on, then a year later they test again, and then a year later they test again. And they see the change over time. And that's a prospective study. As I said, that was 6 to 10 years. It takes a long time to do a prospective study. It also takes money to take it, right? It's a lot of time, effort, and money involved, and that's a short-term prospective study. I could do a prospective study to see how smoking affects lung cancer by taking a group of college students now and having them come back every year until 60 or 80 years from now to see what happens and see if any of them develop lung cancer and if it seems to be related to smoking. That's a long-term prospective study, a lot of time, effort, and money going into that. Gives you a lot of information, but boy, you really gotta wait. You gotta have patience and you gotta have the willingness and the money to be able to do that. So that's a prospective study. We also do a cross-sectional study. Cross-sectional is where we take a snapshot in time. Kind of like if you're trying to find out how old a tree is, how do you know how old a tree is? Well, you count the rings. How can you count the rings? Well, you have to cut the tree down. And then you look at the cross-section and you count the rings. Well, it's a snapshot in time. Unfortunately, with that type of snapshot, the tree doesn't go on living after that. You just finished it off. Hopefully, with most of our cross-sectional studies, the participants get to keep on living. But the idea is that we can get a lot of information quickly, currently. So if we're dealing with the smoking versus lung cancer, we can grab a group of people that have lung cancer or do not have lung cancer and see if they smoke and what their habits are. Or we can grab a group of people that smoke and a group of people that don't smoke and see if they have lung cancer and test. So we have the ability to get information right then. We also have the ability to force the outcome we're looking for, make sure it's part of the study. If we're trying to compare it to lung cancer, with a prospective study, we could go 80 years on this study and nobody ever gets lung cancer. So we just did this whole study and we never even tested anybody for whether they had lung cancer or not. That's tough. Whereas cross-sectional, we can force and guarantee that we have people with lung cancer, and then we can see, well, did smoking have something to do with it? So that's a cross-sectional study. The third and final one is retrospective. A retrospective study. Spect, to look or to see. Retro, behind, back, or in the past. So retrospective, looking behind or looking into the past. A retrospective study is kind of a mix between perspective and cross-sectional, but kind of working the other direction. You can say a retrospective study covers the cross-sectional, you get the here and now, and it gets that advantage of being able to guarantee that you have people with exhibiting what you're looking for, just like you did with the cross-sectional. But then it looks back into the past, getting some of this information that you would get from a perspective study, but you're getting it now instead of having to wait a number of years because you're looking back. So, a lot more powerful than a cross-sectional study, not quite as powerful as a perspective study, but it's still, we can guarantee we have a result in there we're looking for. The problem with retrospective is we may not be able to get our hands on the information from the past that we'd like. We may not be able to get our hands on medical records. The person that we're talking to may not be able to remember how they did this or what they did or why they did it. So, much more powerful than cross-sectional, and a really good way to go, quicker and easier than a perspective, but not quite as powerful as a perspective study. So those are the three types of cohort studies that we do when we're dealing with observational studies. So that finishes up with topic 1C.